integration by parts, right? We have trig integrals. Well, I think you can rule out trig integrals because there's no trig stuff in here, right? But see, we're starting to get all these different methods, and now when you look at it, this could turn out to just be a basic U sub simple problem. It could be. You have to eliminate that as a possibility before you start doing trig sub, right? You don't want to do trig sub on something that you could have done basic U sub on, right? So it becomes hard to like filter through all the crap and figure out what to do to find the path, right? What did I tell you? What have I told you about how to get better at that? Being able to like figure out what you're supposed to do. Practice. You've got to do a lot of problems. You have to. All right, so I look at this, I'm like, okay, basic U sub. Basic U sub, maybe if I pick that to be U, the derivative is 2x. I don't see it, it's not there, right? If I pick that to be U, 2x, no, that's not 2x, it's down the bottom anyway, right? So I rule out U sub. Integration by parts, maybe, but you know what? It looks just like that, right? I mean, it's just like that. So I'm going to try trig sub. All right, and I'm using this form, right? I'm using the form a squared minus x squared, right? I'm using that. So I know my sub is going to be x is a sine theta, right? This is me kind of thinking through what I'm about to do. I'm going to do trig sub because I see that, and that's the trig sub I'm going to do. All right, what's a for us here? So a for us is 1 here. So we're going to let x be what? 1 sine theta, so just sine theta. Same exact trig sub as the previous problem, right? All right, now, what does that tell? Well, okay. What I normally do at this point is I realize that I'm going to need the derivative of this eventually, right? Like I'm going to have to replace dx. So I just do it right now. I'm just going to differentiate. And so I know that this is going to become dx is cosine theta d theta. And so I skipped the part where I did dx over d theta, and I just moved the d theta over right now. So we all right with that? That's my trig sub. That's the derivative of that trig sub. And then I'm going to now figure out what does that square root of 1 minus x squared turn into for us? Well, square root of 1 minus sine squared theta. We just did this, didn't we? And then that's the square root of cosine squared theta, and that's just cosine theta. That's it. All right, so I know now that this is going to be replaced with that. I know that all my x's, my dx is going to be replaced with that, right? So the new integral is, what's this? Cosine theta. Okay, pay attention. Over, okay, what's x squared? See, this is new. The last problem didn't have this. What's x squared? Well, if this is x, you square both sides, x squared would be sine squared, right? Sine squared theta. Am I done? What am I missing? Yeah, I'm missing the dx, right? What's dx? Cosine theta d theta, right? Make sure you account for every piece, right? This piece right here was the blue piece. This right here was the red piece, right? And then the bottom piece there, do I have green? I have green. The bottom piece, the x squared, this right here, we replaced that x with this, right? And we squared it. That's why we have sine squared here. All right, this, unfortunately, is cosine squared theta over sine squared theta. And you could make this problem really hard, or you can make it easy. And I'm going to make it easy. What trig function is that? What's cosine over sine? Cotangent. So this is the same as the integral of the cotangent squared theta d theta. The reason I did that is because that's actually the derivative of something from Cal 1. Is it or not? Hold on. Look at it. Is it? Close? No. Is it? No. It's derivative of tangent is secant squared, right? What's the derivative of cotangent? No. Okay, so it's not, right? We're off. So what do we do with this? Last class we talked about the Pythagorean identities. Where do I want to put it? I'm going to put it off screen. What were our Pythagorean identities? Sine squared x plus cosine squared x is 1, right? The other one we should know is tangent squared x plus 1 is secant squared x. And there's a third one. What is it? 1 plus cotangent squared x equals? Cosecant squared x, right? Those are our three Pythagorean identities. Yeah, so we could replace this with this. Why am I doing this though? Why am I seeing that I should go and replace this with cosecant squared minus 1? Why? Because you know the antiderivative of cosecant squared. See, I don't know the antiderivative of cotangent squared, but what I do know is that if I rewrite this as, using the Pythagorean identity, cosecant squared x minus 1, no, not x, theta, d theta, sorry everyone. Stop. Okay. If I replace this with this off the Pythagorean, everyone see the Pythagorean there? Do I know the antiderivatives of each of these separately? The antiderivative of cosecant squared theta is on your sheet, right? That's on your sheet. And then the antiderivative of 1 would be, in this case, theta, right? Theta. I'm going to continue. So now I have equals, all right, what is the antiderivative of cosecant squared theta? Negative cotangent theta. Why is that? Because, well, it's on your sheet, right? Directly. What formula is that? What number is it? Are you looking at integrals or derivatives? You're looking at derivatives. You're looking at integrals. So it's formula number 9 on the integrals. Formula number 9 on the integrals. Flip one more page over. Nope. Yeah. Formula number 9. Right? You see it? Okay, so I'm using formula number 9 to do the antiderivative of this. And then minus what? Theta. And then plus c. Minus theta plus c. Okay. All right? Now, unfortunately, we're not done. Because our answer is in terms of theta, we need it in terms of x. So I'm going to go now and create a reference triangle. And my reference triangle is going to be based upon what information on the board here? X is sine theta. Wherever our trig sub is, right there. Which is the exact same trig sub we had a second ago. So I'm going to have the exact same reference triangle. So my reference triangle is x is sine theta. And we already showed a second ago that means inverse sine of x equals theta. We just did the arc sine on both sides. So I can replace theta with, I can replace this theta right here with arc sine of x. But I need to figure out what cotangent theta is. Well, negative cotangent theta. So to figure out what negative cotangent theta is, I draw my right triangle. This is theta. This is x. This is 1. Is that all right that I just do that because we just did that a minute ago? And this side we could solve for? Root 1 minus x squared. Now, can you tell me based upon this, do you all understand where I'm getting that? I'm getting some looks of confusion here. A squared plus b squared is c squared, and then you're solving for a. So just call that a, do a squared plus b squared is c squared, then solve for a, you'll get this. All right, so from that, can you tell me what tangent theta is? Tangent would be that, right? Cotangent would be that over that. So my answer here is negative square root of 1 minus x squared over x minus inverse sine of x plus c. Wow, that was the first problem on that homework assignment, right? These are exercises out of the back of a book, right, that I found on my bookshelf, right? That's the first problem. So just to give you some idea of the expectation of things like this, we had to see that this turns into cotangent squared. We had to realize that Pythagorean identity was going to give us this cosecant squared minus 1. We had to realize that we could handle each of those, right? Questions?
Wait.
Yes?
That side of the reference triangle and so forth, is it a correlation to how it kind of goes back to like the original?
Like this part right here?
Yeah.
This right here should 97% of the time. This missing side will be the square root thing that you did the trig sub on. Sometimes the constants are a little weird with it, but 97% of the time, I'm making that number up, 97%. Most of the time, this is going to appear, this right here is going to appear on your triangle. Okay, yeah? All right, I'm going to check our answer. I'm going to check our answer by doing the derivative, right? That derivative, does that derivative look intimidating? Let me try it. I'm going to try and differentiate this. Okay, so I have to do quotient rule on that, right? Quotient rule on that. I'll leave the negative out for now. So negative, here comes my quotient rule. Derivative of the top, 1 over 2 square roots of 1 minus x squared. Okay, that's derivative of the top, and then I have to do derivative of what's inside. I'm doing chain rule. Inside is, derivative is negative 2x. That's derivative of the top times the bottom minus the derivative of the bottom times the top, all over bottom squared. Okay, that is the derivative of this, minus the derivative of arc sine of x, which we showed earlier in this class was this, right? Okay, somehow that better turn out to be, what does it need to turn out to be? The original integrand was this, right? That was the original problem? Or was it x squared? Yeah, that better simplify to be this. Okay, so let's see if we can clean this up. Put these two together. The 2's are gone. That gives me a negative x squared over the square root of 1 minus x squared, and then minus square root of 1 minus x squared. All of that's over x squared, right? But there was a negative outside of everything. So when I put the negative back through, it turns that into that and that into that. And then over here I have this. Right? Okay, let's put these two fractions together. If I do that, I'm going fast here, okay? If I put this together, I need to do this over 1. So I need to put a root 1 minus x squared here and another root 1 minus x squared up there, which kills off that root like that. And now if I put these two together, what happens? The x squareds cancel. You just get 1 over square root of 1 minus x squared over x squared minus 1 over square root of 1 minus x squared. It's this piece. What now? How about I clean this up? This over this, flip it. This is 1 over what? X squared, square root of 1 minus x squared, minus 1 over square root of 1 minus x squared. Common denominator. So x squared. Okay, so I have x squared there, x squared there. I put them together. What do I have? 1 minus x squared on top, right? On the bottom, x squared, square root of 1 minus x squared, right? We're there. Do y'all see why we're there? It's kind of hard to see. Do you all agree that that right there is the same as this? Yeah. Right? The square root of 1 minus x squared is just 1 minus x squared. So if I have two of these factors up here and one down here, I can cancel one and cancel that, and then I've got my original expression. It's there. I'm just trying to convince you that it worked, okay? I went fast, but it does work, all right? Okay, let's pick another one. Let's stick with the same trig sub. You know what? I might pick this one. Or 15, oh, I was saying 15 and 16 look like the same problem, but they're not. Let's do 16. Let's do 16. Square root 1 over x squared square root 16 minus x squared dx. All right, so I look at it, I'm like, okay, nothing I know will get me through this problem. I don't know what to do. But I see a square root of a squared minus x squared. Right? You see it? So I see this, and now I say, all right, a for me is what? Careful. In the formula, this has to be a squared, right? So a would be 4 for me here. So here a is 4. So here's my trig sub. X is 4 sine theta, right? So this is the first time we actually have a 4 there. Before we just had a 1, right? Now I'm going to take the derivative on both sides. Dx would be 4 cosine theta d theta. And what would the square root of 16 minus x squared turn into for us? Let's go through this. I want us to make sure we understand what this turns into. Are y'all okay with these two, though? Any questions here? Why I did this? Just out of curiosity, what if this number was 15 instead of 16? What would a be? The square root of 15. Okay, so if it's not a perfect square, it's okay. It's just now you're going to just have a weird number here. Okay, like if that number was 3, this would be square root of 3. If that number's 4, then that would be 2, and that's nice. But just remember, if you had square root of a number here, like square root of 15 or square root of 3, it's just a constant, okay? So when you differentiate, it just comes for the ride, all right? All right, what does this turn into? Square root of 16 minus square the x, so square that. 16 sine squared theta. And we have a little bit of an issue here because we got 16s and we can't use the Pythagorean identity. Not yet. We have to do one thing first. We have to factor the 16 out of both of those.
Why is it 16?
Well, I don't know why I put, it's 16 here. It's 16 right now.
We put 16 sine squared.
Pardon me?
Not before sine squared?
No, but we're squaring it, right? We're taking that and we're squaring it. So when you square this, you square both, right? Everyone got that? You square both of these, and that's why I put 16 sine squared. Maybe I should have maybe just put this line first. Right, that's what we were doing. We were replacing the x with this, and then now when you square this, you get the 16 sine squared. All right, do y'all see what I've done? Pull a 16 from both of those. Now, what does that become? Cosine squared. So square root of 16 cosine squared theta. And now, because there's multiplication between those, you can take the square root of each one, which would be 4 cosine theta. Square root of each one. Square root of 16 is 4. Square root of cosine squared theta is cosine theta. All right, so everywhere, well, I'm going to replace dx with this, right? I'm going to replace the root that root thing with 4 cosine theta, and any x's that I see straggling along are going to be replaced with 4 sine theta. So now I get to rewrite this whole problem. Integral. Okay, well, good news, I have 1 on top, right? 1 on top. This, what is this for us? It's that squared, right? So 16 sine squared theta. 16 sine squared theta. And just to color code things, this right here is this, and that's coming from this thing being squared, right? Now I have what? What goes next to this being multiplied? 4 cosine theta. Where's that coming from? Well, 4 cosine theta, right, is this root part, and that root part is this part, right, which is that part. Am I done? Oh, one more thing, right? dx. dx needs to be replaced with 4 cosine theta d theta. 4 cosine theta d theta. We now have a trig integral, right? It's now it's an integral with trig functions instead of square roots and stuff. Questions? Where does that come from? Where's that 1 over 16 coming from? I just pulled that 16 on the bottom out. If you pull a 16 on the bottom out, it's a 1 over 16. Okay, what's still in my integral? 1 over sine squared? And what's 1 over sine squared? Cosecant squared? Isn't that cosecant squared? Do you have the antiderivative cosecant squared? Did we just do that? So this is going to be 1 over 16 integral cosecant squared theta d theta. And according to formula number what? 9 again? What does that equal to? Negative cotangent? So how should I do that? I'll just put it like this. Negative cotangent theta plus c. Just we need to understand that this is multiplication, right? Not subtraction. So I'll write it a little different now. Negative 1 over 16 cotangent theta plus c. All right, come on. Ask questions. None? All right, reference triangle. I need a reference triangle. Yeah, oh, yeah, yes.
Well, I was just going to say, so every single thing that gets replaced by theta will be from the reference triangle?
Yes, unless our answer, let's say that this answer was sine theta. Let's just say it was sine theta. We know it, we could figure out what sine theta is right here without solving a triangle, right? But if it's something else, then yes, we'll need a triangle. So I'm going to come back to this reference triangle. Now this reference triangle is going to be different than the one we just drew a second ago, right? So I'm ready to work with that. Here comes my reference triangle. I'm just going to do it this way. Reference triangle. I'm going to write x equals 4 sine theta. We didn't have that 4 before, did we? And remember, sine is opposite over hypotenuse, right? So what I'm going to do first is I'm going to divide both sides by 4 to create the fraction, to create this fraction, right? And now I have opposite over hypotenuse. You see? So my reference triangle, here's theta. Opposite is x. Hypotenuse is 4. Opposite over hypotenuse. Opposite over hypotenuse. That's the definition of sine, right? And then I can solve for this side. I'm not showing this work, but I can solve for this side. It would be square root of 16 minus x squared, which is actually this root thing right here, isn't it? Okay. Now once I have the triangle, I can identify all trig functions, right? And I'm interested in cotangent, which is this over this. This over this. So I should have negative 1 over 16 cotangent is times the square root of 16 minus x squared over x plus c. There we go.
Where did the negative in front of 1 over 16 come from?
Okay, if you look on your formula sheets, the antiderivative of cosecant squared is negative cotangent. And that negative, I just pushed it out in front of the 16. Okay? All right. So that was fun. Let's look at number 15. What's the difference between number 15 and number 16? It's not an x squared. What is it? Right here, it's just what? X. Okay? I want to do that problem because if I do that problem right now, I don't have to change a lot of things here, right? So imagine that this was just x. Okay? And let's get rid of some of these colors. If that was just x, I would still say a is 4, wouldn't I? I would still let this be my substitution. I would still say that's the derivative. I would still say the square root turns out to be that. Yes? The difference would come right here. Let's redo this. It would still be 1 on top, right? But x here would now be what? Just 4 sine theta. Not 16 sine squared theta. It's just 4 sine theta. And then the square root piece here would still be 4 cosine theta. And the dx would still be what? 4 sine theta? D theta. Now, how much does that impact the next line? Quite a bit, right? Quite a bit. Because you've got, wait a minute, hold on. This is supposed to be cosine. Sorry. Cosine. That's dx right there. Cosine. So we get 4s to cancel here. We get cosine thetas to cancel, right? This 4 on the bottom can come out as a 1/4. And then integral of 1 over sine theta now, right? Not sine squared. It's just sine. And that's just what? Cosecant, not cosecant squared. And the antiderivative of cosecant is different than the antiderivative of cosecant squared, right? What is it according to your formula sheets? So natural log of the absolute value of cosecant theta, what is it? Minus? Okay. I thought I heard plus, but plus c. See, different antiderivative. Different antiderivative. And so to get my final answer, I need to know what cotangent and cosecant theta are. Am I going to draw the same reference triangle? Is my reference triangle the same? Yes, because it's based off the same trigonometric substitution. So it's the same reference triangle, but now I need 2 pieces. I need cosecant and I need cotangent. Cotangent's this over this. What's cosecant? Reciprocal of sine. Sine is x over 4, so what's cosecant? 4 over x, the reciprocal. So this is going to be 1/4 natural log of 4 over x minus the square root of 16 minus x squared over x, absolute value, close it, plus c. You could put those two together if you want into one fraction. It's a different answer, right? Okay. Tip of the iceberg here. We still got a ways to go here. How y'all feeling?
Good.
It's okay? So far okay? Let's do this one. Very similar to the problem we just did. Let's do that. I'm going to make a small tweak to it just for fun. Let's go ahead and make that a 5 minus x squared. Just to see how having a number that's not a perfect square in there affects things. Now, I will say this might actually go with a basic U sub. You might be able to brute force your way through this without doing trig sub, but I'm going to do trig sub, all right? So do y'all see the a squared minus x squared underneath the root? Y'all see it? Okay, so to do this, I recognize that a is the square root of 5, right? Not 5, the square root of 5. And then I'm going to make my trig sub x is equal to a sine theta. And then I'm going to differentiate that. dx is root 5 cosine theta d theta. And then the square root of 5 minus x squared would become the square root of 5 minus, I'll take my time through this one, root 5 sine theta. So there's x, right? I've got to square it. And what happens when I square that? I get 5 minus 5 sine squared theta. Because I'm squaring the square root. Those both have a what in them? 5. Pull the 5 out. I get 1 minus sine squared theta. It's the same broken record. This is going to happen every single time, right? You're going to be able to do this, and it's going to turn into cosine theta, but what's going to be in front of it this time? Let's see. Square root of 5 cosine squared theta. Take the square root of each one of those, and you get root 5 cosine theta. Root 5 cosine theta. Pass it. Questions? Are you sure? I'm ready to rewrite the integral. Starting out with x cubed. Okay, this can be a little weird, okay? I need to cube x, right? I need to cube this. So I've got to cube that and that. So when I cube the root 5, here's how I'm going to write it. Root 5 cubed. And then I'm going to write sine cubed theta.